Hey, welcome to Dark Dragon Does Math. How are you today? I'm doing great, thanks for asking. Today we're going to do 8th grade math. So the only reason why, unless you're just really bored and love hearing my voice, to be watching this is you have officially finished all of 7th grade math that I've asked you to learn. So congratulations, you rock. So we're going to start 8th grade math, and I'm kind of, instead of going chapter by chapter and saying do this, do that, do this, do that, I'm more taking it into parts. So part 1 here is learning about exponential notation, and then 2 pieces of exponential notation and solving exponential problems. That's the power rule and the product rule. So, excuse me, the product rule and the quotient rule. We will not do the power rule just yet. So we're going to go through some of these. The first thing we want to do is identify the base and exponent of each expression. So the base of an expression, if I take a short sidetrack, the base is the number multiplying itself, and the exponent is the number of times it is being multiplied. So really, if we look at these 3 examples, the base is the big number and the exponent is the little number. It's basically base to the power of exponent. Okay, so for this first one, the base is 10, so, and then the exponent is 5. So the base is 10, the exponent is 5. That means that this number is equal to 10 times 10 times 10 times 10 times 10. 10 times itself 5 times. And we're not going to work out that math right now. I just want to go over what's going on. So this one is the base is -7. We want to make sure we have the negative there. And then the exponent is, again, 5. And then finally, this last one, the base is 0.2, and the exponent is 4. So, if I wanted to put the following, write the following into exponent notation, what that means is I'm going to take these numbers, 1/3 times 1/3. That's 1/3 is the base because that's the number multiplying by itself, and the exponent is the number of times it's being multiplied. So since this is 1/3 times 1/3, the base is going to be 1/3, and the exponent is going to be 2 because it was multiplied by itself twice. For this one, we have 5, 5, 5, 5. The base is 5, and since there's 4 of them, the exponent is 4. And the base is a, and you might be saying, well, that's not a number. No, you're right, it's a variable, but it's still multiplying by itself 3 times. So once we're getting to 8th grade, we're not solely worried about numbers all the time, and we did this in 7th grade and a little in 6th, but we can work with variables as well. So in this case, this is a variable multiplied by itself 3 times, where a is the base and 3 is the exponent. Alright, so this right here, I'm going to use a couple facts to help simplify several questions here. So it says simplify each of the following expressions into exponential form. So before I can do that, I need to go back and explain 2 rules. Okay, rule 1 is called the product rule. So the way the product rule works is that if you take any exponent in base, say x in a times x times b, this is always the same as xa plus b, okay? Basically one exponent. So for example, if it was x cubed times x squared, this is going to be equal to x to the power of 3 plus 2, which is x to the power of 5. Now, the way this works is, think if I had 3 x's, 1, 2, 3, and 2 more, times x, so I've got my x cubed and my x squared, and then how many is that all together? Well, that's 5 of them, so this would be x to the power of 5. So that's the product rule. And there's one more called the quotient of powers, or you could call it the quotient rule. I don't know if that's super not okay, but so the quotient of powers is if I take, say again, x to the power of a, and this time divided by x to the power of b, this is going to be equal to x to the power of a minus b. So again, the way this works is, let's take 3 and 2 again, x to the power of 3 divided by x squared. Well, that's the same thing as x times x divided by x times x, right? X to the power of 3, x squared. And what happens is x over x ends up canceling out, and so does x over x again. So those two cancel out, and I'm left with just x alone. Or we could have just said this is going to be the x to the power of 3 minus 2, and 3 minus 2 is 1. And just an FYI, or a reminder maybe, anytime you have something to the power of 1, you don't have to write that little 1. You can write the 1. It doesn't really matter. But we usually do not. And mathematicians certainly do not. Alright, so let's use those two things to solve these questions. So we want to put them into simplest exponential form. So 7.2 times 7.2, so our base is going to be 7.2. And that's not that hard. I always try to put parentheses around if it's not something that's just a number. Mostly being it helps me personally keep things separate in my head, and it helps me as a teacher, if you're doing that, keep things separate on your paper, so it's a lot more clear. So here we do, this is multiplication, so this is going to be the product rule, and it's to the power of 3 and the power of 4, so that means this is going to be 7.2 to the power of 3 plus 4, which is 7.2 to the power of 7. The second one, p times p to the 8th. So remember, p, there's no p that's p to the first power. So this is like p to the power of 1 plus 8, which is p to the 9th power. This next one, this is where we get, oops, I don't need the whole thing, I just need that. This next one can be a little tricky. We're getting numbers involved. So I just want to point out that though it looks more complicated, and there's more than one that we're going to have to do here, the numbers are still numbers. This is still, and I like to put the numbers next to each other first. 2 times 5, and then we're going to multiply that. Let's do the x's next to each other. X squared times x to the 5th, and then y to the 4th times y. Now all I've done is I've gone through and I've just reordered everything. So I took the two numbers together, the two x's together, and the two y's together. And that makes everything a little bit simpler, at least for me. I know what 2 times 5 is. 2 times 5 is 10. I know that x squared times x to the 5th is x to the 2 plus 5. 2 plus 5 is 7. So 10 times x to the power of 7. And then finally, y to the 4th, and remember y alone is y to the first power, y to the 4 plus 1 makes y to the 5th power. And this is as simple as we can get. Remember, numbers are numbers, and x and y are not the same variable. They're not going to combine. They're not going to simplify. It's not going to turn into something xy. It's got to stay like this. So x 10 times x to the 7th times y to the 5th. Now it could be in any order. It could have been x first. It could have been y first. It doesn't really matter. But this is the final answer. This next one, we're going to use the quotient rule again. 2 to the power of 10 divided by 2 to the power of 5. So this is like 2 to the power of 10 divided by 2 to the power of 5. Remember, this is the quotient, power of quotients, quotient powers. This is going to be 2 to the power of 10 minus 5, which is 2 to the 5th power. And I don't know about your brain, but in my mind, when I see this, I'm thinking, okay, I'm basically canceling out 5 of these, so I don't necessarily do this step in my head. I can jump from here to here, and I maybe encourage you to practice that as well. 5 of these are canceling out. So this one, h squared, and I'm going to split this up again to h squared times k to the 5th power divided by h times k to the 4th power. So I'm going to put the h's over each other. I have an h squared divided by an h, and then that is multiplied by k to the 5th divided by k to the 4th. So again, it's kind of the same thing. I'm just maybe simplifying a little bit. So here, h squared divided by h, where there's one of them cancels out, so I have one h left. 5 minus 4 gives me 1 again, so this simplifies to hk. There's a lot going on in this one. Lots of 4 nines, 4 nines, 4 nines, 4 nines. But thankfully, because it's all the same base, I can just worry about the tops. I can say, okay, this is 4 nines to the 6th, 4 nines to the 5th, 4 nines to the 4th. If I add all these up, 6 plus 5 is 11, plus 4 more gets me 4 ninths to the 15th power. And then if I add all these up using the product rule, 3 plus 3 is 6, plus 4 is 10, over 4 ninths to the 10th power, and it's just 15 minus 10 gives me 4 ninths to the 5th power. And then finally, this one, it's going to be a lot like the one I did right here, where I reordered things. I'm going to take all the numbers out first, so the top number is 3 times 4. And then we have, let's do the x's next, x cubed, and then 1z to the 4th power, all over, I have a 2 and a 3, so 2 times 3 times x times z. Simplify the top now. 3 times 4 is 12. I have 1, 2, 3, 4, 5, 6 x's, and then I have 4 z's over 2 times 3 is 6, 2 x's, and 1 z. And then we're just going to simplify. 12 divided by 6 is 2, x to the 6th divided by x squared, 6 minus 2 is 4, so x to the 4th, and 4z minus 1z gives us z to the power of 3, and that's it. And I hope that was helpful. What I want you to do next is you must do the back, and what you'll notice, the back is extremely similar to what you just saw, so you can put it all right back into practice. My thing over here is just a second away, so math! Have a good day.